Hi everyone, today we're going to be doing lesson 3-4A. Our objective for today is to solve multi-step inequalities, including inequalities that have no solution and all real numbers as a solution. Okay, so let's take a look. I'm going to compare an equation to an inequality. For both of these, I'm going to draw my lines down. So I have negative 3t minus 6 equals 15. The first thing I do is send home my acquaintances by adding 6 to both sides. This will cancel out, and I'm left with negative 3t equals 21. Over here, I do the exact same thing. I have negative 3t minus 6 is greater than 15. I'm going to send home those acquaintances first, just like I did with the equation. And I'm left with negative 3t is greater than 21. So my next step would be to send home my besties in this case, in which case I'm going to divide both sides by negative 3, divide by negative 3. This will cancel out, and I will have t equal to negative 7. So if I put negative 7 in for t, this will be a true statement. Now for this one, I have to divide both sides by negative 3, just like I did on the other. But as you recall from my previous videos, when you divide or multiply both sides by a negative number, just send home your best friends. Your friends are going to flip out. In other words, I have to flip that inequality when I multiply or divide by a negative number. But I still end up with negative 7 over here. So for this one, the solution to this inequality is all numbers less than negative 7. Excuse me. So my equation has only one solution. My inequality has infinitely many solutions. It goes, every number that's less than negative 7 will be a solution. My lines are drawn there. I didn't need to do that because I did that already. But as you can see, my one solution over here is right at negative 7 here. It doesn't include negative 7, but it's every number less than it. One solution, many solutions, infinitely many. Let's do another one. I have 45 is less than or equal to negative 15 times quantity j minus 3 plus 3. I'm going to draw my lines down. And the first thing I'm going to do, feed my birds, or distribute. Negative 15 times j is negative 15j. Then I have negative 15 times negative 3. That's going to be a positive 45. And I still have my plus 3j, so I don't want to lose that. On my left side, I have 45. I have some like terms I can combine. I can combine my negative 15j with my positive 3j. And that will give me a negative 12j. plus 45. And on my other side, I still have my 45. And bring down my inequality so I don't forget what it was. Get buried in there. Next step, I'm going to send home my acquaintances. Subtract 45 from both sides. Subtract 45. (45 minus 45 is 0. Let me make my lines a little longer here. This cancels out. I'm left with negative 12j. And so 0 is less than or equal to negative 12j. Last step, I got to send home my best friends or divide by negative 12. Remember, I'm dividing by a negative. Therefore, my best friends are going to flip out. 0 divided by negative 12 is 0. Flip that inequality. They flip out. And I am left with j. Now, I don't like the way this inequality is written. I like to have my variable on the left, so I'm going to rewrite it with my j on the left, my 0 on the right, and because I changed the order of my inequality, I have to turn my sign around. Notice it's pointing at the j. I want to keep it that way. So j is less than or equal to 0. If I were to graph that, I would have a closed circle at 0, and all of the numbers that are less than or equal to 0 would be a solution. So all those negative numbers and 0. Let's try another one. I'm going to draw my line down. Hopefully I can do it straighter this time. I'm not very good at drawing straight lines. Oh, that was even worse. We start by distributing. I think I'm going to need a lot of space, so I'm going to draw my line down far. We start by distributing on the right side. 2 times t is 2t. 2 times negative 1 is negative 2. And I have negative 5t. On my left side, I have 5 plus 4t. And my inequality is a greater than. I'm going to combine my like terms. I have 2t, negative 5t. That gives me negative 3t. Minus 2. Some of you don't like to bring down everything on, if you haven't done anything to that side. I kind of like my things to line up, so I always bring them down. Okay, so now what? Well, let's go to the bigger party. I have more t's over here than over here. So I'm going to add 3t to both sides. Just like if it was an equation, I'd always go to the bigger party. So now on my left side, I have 5 plus 7t. Excuse me again. Hope that wasn't too loud. And over here, I just have negative 2. I subtract 5 from both sides. I'm left with 7t after this cancels out. And negative 2 minus 5 is negative 7. I'll bring down my inequality sign. Now I just have to divide both sides by 7. I'm not dividing by a negative number, so my inequality doesn't flip. This cancels out. And t will be greater than negative 7 divided by 7, negative 1. So at negative 1 on my number line, I'm going to have, let me change colors, an open circle because it doesn't have the or equal to, and all numbers that are greater than negative 1, so my inequality, my solution will go to the right. Let's look at a word problem. Nathan's lost his mother's favorite ring, so he decides to rent a metal detector to try to find it. A rental company charges a one-time rental fee. That's an important thing to know, $15, plus $2.75 per hour to rent the metal detector. He only has $50 to spend, so we want to know how long he can rent the metal detector. What's the maximum number of hours? So, if I were to write this inequality, we would have, I didn't want to do that. We would have our one-time rental fee of $15. And we're trying to solve for how many hours he can rent it. So he would pay $2.75 for every hour. So since we have that per hour and we're trying to solve for hours, that's where our variables are going to go. He has $50 to spend. So my inequality, he can't spend more than $50. He has to spend less than, but he could spend exactly $50. So just like any inequality, I'm going to draw my line down. I subtract 15 from both sides. And I get 2.75 $2.75 times the number of hours. Has to be less than or equal to 35. 50 minus 15 is 35. Now my next step is to divide both sides by 2.75. If I do 35 divided by 2.75, I get 12.72 repeating. That's a weird number. The hours would be less than or equal to 12.72 repeating. Now the question is, what's the maximum number of hours? That's kind of a trick question. Depends on, can you rent it for partial hours, or is it only full hours? If it's only full hours, you could rent it for 12 hours or less. You can't rent it for 13 hours. He wouldn't have enough money for that. So assuming that he can only rent it for a whole number of hours, or they charge to the nearest whole number of hours, it would be 12 hours would be his maximum. Okay, now I have some special cases. These might look familiar. As you recall, we had some special cases when we solved these problems in solving equations. First thing we do is feed the birds. 14, 2 times 7, minus 2 times 3n is 6n. On the left side, I have 14 minus 6n. You'll notice right away I have an identity. What's on the left is exactly the same as what's on the right. I could add 6n to both sides, and you'll see that my variable is gone. Cancels out on both sides. And I'm left with 14 equals 14. This is a true statement. And as you recall from our previous chapter, if our variables cancel out and we end up with a true statement, our answer is infinite solutions. I could put any number in here and it will be true. Now let's solve my inequality. I'm not going to walk through the whole thing too much because it's exactly the same as the left side. I have my minus 6n, 14 minus 6n on this side. I have my 14 minus 6n on the other side. And my 6n's will cancel out when I add 6n to both sides. I end up with 14 is less than or equal to 14. And this is a true statement. I don't have a variable. So, pretty much the same thing in this case. Not in all cases, but in this case it is. So, if a true statement occurs, the solution is all real numbers. So, we're just going to call ARN. You do ARN, all real numbers. Any real number I put into this inequality, I will get a true statement. Of course, they're not all going to be that nice. Let's look at this next one. Get my pen back. Again, both of my my left side and my right side are exactly the same. The only difference is one has an inequality and the other has an equal sign. When I combine the terms over here, I get 4p plus 6. And on this side, I get 4p plus 3. If I subtract 4p from both sides, you'll see that it gives me 3 equals 6. Well, then I ask myself, is that true? Does 3 equal 6? Oh, obviously not. 3 and 6 are different numbers. So that is not true. On this side, I'm not going to show every step along the way because they're all the same, but I would end up with 3 is greater than 6. Because I would do the same thing over here as I did over there. Is 3 greater than 6? No, that's not true. So if I solve my inequality and I end up with an untrue statement, there's no solution. So if the variable cancels out with an inequality and the statement is true, your answer is all real numbers. If the variable cancels out and the statement's not true, it's no solution. That is it. Have a great day, and I'll talk to you soon.